Telepresence robots are becoming increasingly popular for remote communication and exploration, offering safety and reducing carbon emissions. However, research shows that operators struggle with speed control and maneuvering, leading to longer task times and collisions. We introduced TeleDriver, an interactive system inspired by driving simulators, which translates driving actions into corresponding telepresence robot movements. Although the prevailing trend focuses on creating interactive systems for desktop and mobile devices, we foresee the development of specialized stations for operating telepresence robots. These stations could be shared resources in offices or homes, much like the dedicated audiovisual stations in libraries or phone booths in many workplaces. In TeleDriver, the direction of robot is controlled by the steering wheel. The rotation of the steering wheel is mapped to the rotation of the robot using a linear function. The shifter is used to switch between forward and reverse motion. The speed of the robot is controlled by gas and brake pedals using a different linear function. We conducted a study comparing TeleDriver to Omni Robot's default app, assessing speed, accuracy, and user perception among drivers and non-drivers. Another aim was to see if drivers could apply their driving skills to our proposed system. In the study, participants maneuvered the robot through an obstacle course and returned it to the start, ensuring all robot control functions were utilized. Results showed that drivers using TeleDriver were 23% faster and made 39% fewer errors compared to the default method. Conversely, non-drivers using TeleDriver were 26% slower and made 147% more errors compared to the default method. The performance of both user groups was similar when using the default method. Crucially, both user groups showed improvement over trials with TeleDriver, consistent with the power law of practice. By the last trial, drivers were 17% and non-drivers 13% faster than their initial attempts. Likewise, drivers using TeleDriver saw a 58% reduction in error rates in the last two trials compared to the first two, while non-drivers experienced a 63% decrease in errors in the last trial versus the first. These results suggest that TeleDriver is an effective method for guiding telepresence robots for both experienced drivers and novices, as those without driving experience quickly adapt to the system.